Hello everyone, this is going to be the beginning of my ecosystem simulation devlog. So, in this devlog, I want to accomplish making an ecosystem that has bunnies, predators, food, water, mating, and all of that to see how it would function in a real ecosystem. I'm doing this all in Roblox Studio, so hopefully I can complete it. And in this episode, I'm just going to be going over what I have done so far and what I will do in the future. So, just an empty base plate. Everything is being done on the server. So I have the bunny in replicated storage. I had to give it all its arms and stuff so it would actually function with the humanoid. And uh, it has a status handler and the NPC handler. I have the food handler, which spawns food, and normally it just keeps spawning food, and then it like decays after. I'll make it like 15 seconds. And yeah, so that's the food handler. It basically just spawns in random food at random positions, and then it waits, and the bunnies track down that food, but we'll get to that later. So let me just add that back in. Alright, there we go. So it clones the fruit, and then it just spawns it at a random position. And I plan in the future to make that position around the bunnies, but I might actually just do it anywhere, like anywhere around the map, cause that's more realistic. All right, so now to the bunny handler. This basically just spawns the bunnies, and I have a little attribute down here so you can easily control all the bunnies that are spawned. And uh, I actually plan on making a max, so like a max of 150, but that's just for myself since I don't think anyone else is going to be using this. So I'll just set that back to like 20. So I have the bunny, I have the num of bunnies, which is just the attribute, and then I do a for loop for all the nums of bunnies. So I repeat this that many 20 times, and I just clone the bunny, uh, put its position 15 times the last one, which is not very efficient. I plan on fixing that later, but then I make it parent workspace. So that is the bunny handler and food handler. I think instead of going into the NPC handler, which is just what controls like the pathfinding and all of that, let's go into the let's try and go into the status handler. So basically how I have this running is I was trying to make it efficient and easy to add more and more like status statuses to the bunny, so I don't have to like recode everything every time I add a new thing for the bunny, like attack or something like that, or run away. I don't have to add an entirely new, and like I don't have to recode the entire NPC handler. So we'll go into that and see how I actually use the status. But I have the status and I have the head. So I I set the default status value to wandering every time, and then I check in here in the food, which is just where I put all the food in a side of folder so I can loop through it. And then I do if the magnitude between the food and the head is less than 30, then I set the status to food so it will start chasing food. And that's all the statuses I have right now, but in the future I'm planning on doing a fox folder that has all the foxes, and then I'll loop through all those, basically do the exact same thing here, and then I'll change it to fox or like runaway, which will be very efficient, I hope, and I'll be able to do it uh many times over and over. So now in the NPC handler, I just get all of my uh, variables. I set my agent args because it's a custom NPC. It's not like a default rig. And then I have the timeout function just for so I can save some time. Basically, if you don't know what a timeout is when you're pathfinding, it's if the bunny cannot reach its point of destination in time, then just break it and redo. That's basically what it's doing. And then I have the find path function, which I think was a great idea to make its own function that I can just call every time I need to do it. Because the find path function can act as a runaway, it can act as a chase, it can act as a wandering, it can act as all this different stuff. Because in here I add the wait, which is how much time it has until I will return. Oh, wait a minute. Okay, never mind. So basically, this is how much time I have until the bunny has to finish its path or get to its destination. And also, let's just go through the function. So I have the target, which is where the bunny has to go to, and I made it very efficient to me, so there's not going to be as many errors because sometimes you forget if you're supposed to plug in a position value or if you're supposed to plug in a instance value. So I made this nice little handy dandy if statement where if it's checking if the target is a vector 3, and if it's not, then it checks if the target is a base part or if the target is a mesh part. Actually, let me add if it's a union part or target is a union part. Oh, wait, union operation. And then if it is one of those, then I set the target to the target dot position. So it does it on the server side, so I don't have to do it. And then going past that, I just make I don't really need this actually. I'll just make this target. I was just doing that to like, I was debugging because it wasn't working before I had this. So then I create a new path with pathfinding, add in the agent args, which just basically tells the pathfinding service what it has to avoid and like how it has to avoid it. So then I get the if target is not equal to nil. So like, cause I had a problem where like the target would equal to nil somehow, and I didn't really understand it, so I just added this. And if it's not that, then I just make the status equal to wandering, and this repeats every second, so then it can just redo that, which I thought was efficient enough. So then if the target's not equal to nil, I compute the path, and then I do it from head dot position to the target, and then I get the waypoint, and then I make a for loop for each waypoint. You should know this, and since it's a bunny, I do hum.jump equals true, and then I do hum move to point dot position, and then I do if not timeout. Timeout's my function up here, which just checks if the if not timeout. It's really not that good, but you know I do it anyway. Like uh, where am I? All right, up here. If not timeout, move to actually, honestly, because if I was doing this before, I would have to have a variable. It's fine. Then return false, and then else return true. So if this finishes, then I'll return true, which means the path was completed. Alright, well, here, let me show you this magnitude, because I thought I was genius for this. So, so when you're doing this, and you have to do a lot of if statements, you're going to have to use magnitude a lot, like a lot, a lot. So, basically, I have the function mag, and then I have post1, post2, and then the max that it can be. And then it does what it normally does, but it returns true or false. And I'm just genius for this. I'm actually gonna add a true, or not true. I'm gonna add a uh um check. So I'm gonna add a check. So I'm gonna go. I don't want to make a color sequence. If check, then I'll do all this. And let's just tab that. And then I can do else. I'll just return this. Because I was actually using this earlier and I was having problems with it, so I just decided not to use it because I didn't want to check if it was this, I just wanted the magnitude. So now that should work. Alright, now coming back into here. So this is my first one, and look how easy it is to do the wandering now. Because I have all that other stuff set up, it's so easy to do everything. So if status.value is equal to wandering, then local random point is equal to head.position plus, it can either be 10 behind, 10 in front, 10 to the side, 10 to the other side. And then I'll find the path with a random point and 2-second wait time. Alright, and then else if status.value is equal to food. This is a lot more lines, but it's not really that many. It's 91, 66, so it would be 25, I believe. Yeah, 25. So I make a local food in area, just a default table. Food positions is a default table, and then I loop through the food folder. I check if the magnitude between both of the values is less than 30. Then, if it is, I insert the food in area, which is just going to be the food. And then I also, well, in food area, I insert the food. And then in food positions, I insert right here. Let's change that to, actually, I also have to do comma true. Alright, and then, so I get into food positions and I add the magnitude between head dot position and v dot position. Let's actually change this to uh, mag. And then I'll do comma. So I'll just do a random value and then comma false, like that. Then I'll do a, there we go. So that should work. And then I sort the table. So I sort the food positions table, and since it's magnitudes, they're all going to be numbers, so I can do that. And then I get the food positions 1 because that will be the lowest value, and that's how I get the closest pose or position. And that it took a little bit to figure that out and to figure out that I had to use magnitude. And then I make a food variable, which is just set to nil by default. And then after that, I just make a simple loop for I comma v in I pairs food in area. So I'm just looping through the food in area, and then I do if closest pose is equal. Let's just get this like that. So we're checking if the closest pose is equal to the food position, or is if closest pose is equal to the magnitude between the food position and the bunny, then closest pose is equal to v dot position. So then we're actually getting the position instead of the magnitude, and then we're setting the food equal to v, which is also the food. And then we break if we find it, and then we check if the path between closest pose comma 2 is true, and that's also running it all. And then if it is true, then food if food then I always hate doing this stuff like this, but we're checking if the food is still there, because when there's multiple bunnies, one might get to the food before the other one, and if that happens and it eats that food before the other one, then it will error because it's trying to destroy a food object that's not actually there. So then we're checking if the food is still there, then we destroy the food. And yeah, that's basically everything. And I mean, it's not the best, but it's not that bad. It's pretty efficient, and I'm pretty proud of it. Yeah. Let's actually check if this works. So basically, I'll you can see how the bunnies function if I didn't do an error with that magnitude thing. Uh, what are they doing? Is there a piece of food right there? I don't see no food right there. Oh, they were just lagging. Okay, let's move some of these out of there. Well, that's weird, but you can. Okay, now they start to move. But let's just follow these. So you can see how they go for the closest one. Closest, closest, closest. They might. Oh, that one, and then that one. Yes. All right. Will they go? Oh, that was weird. They split up. But yeah, I find this pretty cool. The food randomly spawns, and the bunnies follow it. And if there's no food in the area, it goes back to wandering. And if we actually go into one of the bunnies, go to status, it's like food, wandering, food, wandering, food. And yeah, that's basically how it's gonna go. So I hope you enjoyed the first devlog for this ecosystem simulation game. It's not really gonna be a game, but it's just gonna be like a little project for me to do. So I hope you guys enjoyed, and I'll see you guys in the next devlog, hopefully. Hopefully. Bye, guys.